My name is Bruce Clark and I work for the Queensland Curriculum and Assessment Authority. Today, I'm going to be taking you through drones as a context for learning and linking drones to the Australian curriculum and more specifically, the critical and creative thinking aspect of the Australian curriculum. In both education and in general, there is much discussion about the skills young people will need in the future and the role that they will play in supporting them to live and thrive. As farmers, emergency services and transport industries realise the potential of unmanned aerial technology, so too are teachers. Drones are fun, engaging and accessible technologies. More and more, we are understanding how drones can make the curriculum come alive by providing opportunities for our students to imagine the future and explore possibilities. We have always had our thoughts and dreams for the future represented in modern culture. From the invitation to meet the Jetsons, everyone's favourite family of the future, to the order issued by Captain Kirk, beam me up, Scotty, in those classic 60s screen icons. In the 90s, we were tantalised with the prospect of hoverboards, time travel, and drones that film the news in Back to the Future. Today, we see these ideas that were represented on the big screen as a reality in our lives. These are exciting times, yet sometimes uncomfortable times. The pace of change we are all experiencing is rapid, so much faster than humans have ever experienced before. It has always been and remains difficult to predict what the world will be like in 10, 20 or 30 years, or to predict with any certainty what the jobs of the future will be. So what knowledge, skills, attitudes and values will today's students need to thrive and shape their world in the future? In 2018, this question was raised by the OECD, and it's one that educators are driven by as they plan and implement the teaching, learning and assessment that prepares students for 2030 and beyond. The challenge for teachers is real. How do we engage and motivate our students today and teach them the capabilities and skills that they'll need for the future? The use of drones offers an opportunity to, in some part, answer this question by providing a unique and exciting context for learning that enlivens the curriculum. As educators, we have to ensure that we're using drones in authentic and innovative ways while maintaining strong alignment with the curriculum. STEM, science, technology, engineering and mathematics is a natural home for drones. But for the purposes of today's presentation, we'll focus on two learning areas, science and technologies. The Australian curriculum has been designed to develop successful learners, confident and creative individuals who are active and informed. And to achieve this, the curriculum is built around disciplinary knowledge and capabilities. This diagram highlights the three-dimensional nature of the Australian curriculum with 3 cross-curriculum priorities, 8 learning areas, and 7 general capabilities. In our drones example today, we'll bring together the disciplinary knowledge of science and technologies with capabilities. The Australian curriculum includes 7 general capabilities, and today we're going to focus on one of these, critical and creative thinking. So, drones plus science and technologies plus critical and creative thinking equals engaging, motivating, future-focused learning. The iterative nature of critical and creative thinking is what drives innovation in both science and technologies. The ability to think critically and creatively about ideas, data and information, and be able to reflect are the future-facing skills our students will need to become resilient problem solvers, able to operate with confidence in a complex, information-rich and globalised world. The key ideas for critical and creative thinking are organised into 4 interrelated elements: inquiring, identifying, exploring and organising information and ideas, generating ideas, possibilities and actions, reflecting on thinking and processes, and analysing, synthesising and evaluating reasoning and procedures. We will work further with these elements at a later point in this presentation. The general capability of critical and creative thinking is integral to the learning areas of technologies and science. These learning areas rely heavily on critical and creative processes for innovation, problem solving, and testing hypotheses. If we consider our previous slide as the structure of our curriculum, and now add the layer of a real world and exciting drone context, that is, the prospect of exploring a new planet, the combination of this and the curriculum lead to rich learning experiences for our students. With NASA's latest drone, Ingenuity, set to hitch a ride to Mars on Perseverance lander in February 2021, this real-world example of changing circumstances gives rise to an authentic context for our students to engage in critical and creative thinking. Imagine having students consider the challenge to modify a drone to fly in a Martian atmosphere. For adolescent learners in particular, a sense of wonder drives their engagement, and within the inquiry element, students are invited to explore possibilities without limit, ask questions, and push boundaries. So what would this look like in practice? Today, I'm going to introduce you to Cathryn Menzler, a colleague of mine here at the QCAA. She is going to take you through links to the curriculum and what this does look like in practice.
Thanks for that, Bruce. If we take the time to investigate further into the critical and creative capability, we can clearly see that the skills that we're expecting to see in our students mirror that of the innovators at NASA. At NASA, innovators asked, what challenges does the atmosphere of Mars create for powered flight? And how can we prove it's possible? In our classrooms, we could ask students to imagine themselves working at NASA. In science, students could formulate an hypothesis around the impact of changing gravity on the lift needed to fly a drone. In this case, of course, a simulator would be used to gather that data. In technologies, students could investigate the materials and systems needed to solve the problem and articulate this in a design brief. Students are required to think critically and creatively as they consider alternatives. At NASA, the options for flight control were considered, taking into account that remote piloting was of course not possible. In science, students should or could consider the alternative power sources available on Mars, such as solar. In technologies, students could consider possible solutions to remote piloting and identify strengths and weaknesses when weighing up this alternative. Students are required to think critically and creatively as they analyse, synthesise and evaluate reasoning and procedures. Once the mission has begun, NASA will need to consider questions such as, how do they respond to the data they have from their first flight? And have they entertained the idea of complete failure, and do they have contingencies? In science, students need to use their knowledge of the forces involved in drone flight to identify the evidence needed to draw a conclusion. And in technologies, students would consider all the design factors and develop a plan to manage these factors to realisation. Students are required to think critically and creatively as they reflect on their own thinking processes. Checking for flawed logic in transferring knowledge about flight on Earth as it is transferred to the design of technology for Mars requires careful and considered reflection by every NASA engineer involved in the design process. In science, students need to critically evaluate against a set of criteria the steps they plan to use in collecting data. In technologies, evaluation is an integral part of the design process. Students also use criteria to reflect on their thinking to refine their ideas. Drones provide a real-world engaging context for our students to practice the skills and develop the dispositions needed to be critical and creative thinkers. The technology itself is accessible for students of all ages and schools of all circumstances, whether it be through having a single drone, a set of, or engaging with an online simulator. By linking both science and technology learning areas, students are provided with an opportunity to inquire, generalize, reflect, and analyze, and as they explore the original challenge to modify a drone to fly in a Martian atmosphere. With NASA just months away from the realization of years of critical and creative thinking, there has been time to reflect. Daniel Loughney, executive of NASA's Technology Transfer Program, has posed, technology is a means to an end, but sometimes there are more ends than anticipated, and the technology created for one purpose here at NASA finds new life in applications for the US industry and daily life. Daniel quite rightly points out that there are obvious benefits to society when such innovative and groundbreaking projects are realised. It's our role as educators to prepare students with the knowledge and skills for them to become the next generation of critical and creative thinkers, pushing the boundaries of science and technology. Drones present a unique opportunity to motivate and provoke inventive thinking. How will you use this context to inspire your students to thrive and shape the future? Thanks for joining us.